Merge intervals, combine overlapping ranges. Here, 1, 3, meets 2, 6, so they merge into 1, 6. Example 2, 1, 4, and, for 5, touch at 4, so they merge into a single interval, 1, 5. If intervals arrive in arbitrary order, a single left-to-right mental scan does not help. You jump back and forth on the timeline to hunt for overlaps. That is messy and does not give a clean one-pass merge. Sort by start time. Then the story is one-dimensional, read intervals left to right. Each new interval only has to meet the last merged piece, not the whole list. That is what makes a single sweep work. Zoom in, the next interval starts at 2, which is not after the current end 3, so they overlap. The merged end is the larger of the two ends, here 6. When the next start is past the current end, there is a real gap. Finish the current merged interval and start a new one. We keep one active merged interval and walk the sorted list. Seed result with the first interval, 1, 3. That is our active range until something breaks the chain. The next interval starts at 2, which is not after our current end 3, so they overlap. Merge by setting the active end to the maximum of both ends, 6. 8 is greater than 6, so there is a gap. Lock in 1, 6, as finished, and treat 8, 10, as the new active interval. If a later interval like 9, 9, lies completely inside the active range, the condition still holds, but the end does not move. The interval adds nothing new, so we skip it. Finally, 15, 18, starts after 10, so we commit 8, 10, and take 15, 18, as the last piece. One loop with a max on the end handles every overlap case. N is the number of intervals. Time is O of n log n in the usual solution. We sort by start, then walk the list once and merge into the last interval when overlaps occur. If the input is already sorted, that walk is linear. Space is O of n for the output list, and typical sorts use O of log n auxiliary stack space. Pseudocode for merge intervals: sort by start, keep one active interval and a result list, merge overlaps in place, otherwise append a new active interval. If there is at most one interval, nothing to merge. Return the input unchanged. Sort by first coordinate for a left-to-right scan. Allocate the output list. Active is the current merged interval we may extend. Store the first interval in result. Walk every interval in sorted order. Overlap or touch when next starts at or before the active end. Merge by taking the larger of the two ends. Otherwise next start strictly after the active end. Use this interval as the new active. Append the new active to result. Return the merged list.